At any crime scene, pretty much every surface has the potential to tell a story. But how in the world do investigators read a language that's written in blood? Well, that's exactly what we're about to find out.
Okay, so you look at a scene like this, and to most of us, it just looks like complete chaos, a random, violent mess. But to a trained investigator, this is a roadmap. Every single drop, every smear, it's a clue in a story that's just waiting to be told.
And that's the key, isn't it? Bloodstain pattern analysis is, for all intents and purposes, a language. And once you learn the vocabulary, the grammar, the story of what happened starts to become crystal clear. So, before we dive into the vocabulary of this language, let's take a second to understand why these silent storytellers are so incredibly important to an investigation. It really all comes down to one word: reconstruction. These patterns are like a three-dimensional puzzle. They can help investigators figure out where people were standing, the way they moved, and sometimes even the kind of weapon that might have been used. It's all about turning a still, quiet scene into a dynamic sequence of events, the how of it all. So, if we're going to read this language, we have to start with the basics, right? We have to learn the alphabet. And that means getting a handle on the fundamental physics of a single drop of blood. And it all starts with what seems like a really, really simple question, but the answer is the key to pretty much everything else. Why is a drop of blood round? Well, the answer is this incredible force called surface tension. Just imagine a tiny, invisible net pulling all the blood molecules together, holding them tight. This force is so strong that it pulls the drop into the most efficient, compact shape possible, a sphere. And get this is where it gets super cool. That exact same invisible force that lets this little water strider literally walk on water, that's what keeps a drop of blood in a perfect sphere as it flies through the air. It's this beautiful, delicate piece of physics that's absolutely crucial to solving crimes. Okay, so we know blood travels in these perfect little spheres. Now let's see how this story changes the moment that sphere hits a surface. This, right here, is where the real detective work kicks in. First up, let's talk about height. A drop that falls just a few inches is going to be pretty small and neat. But a drop that falls from several feet up is moving way faster when it hits, right? So it splatters into a much wider stain. The size of that drop can tell us a lot about the height it fell from. Now, where it lands is just as important. On a super smooth surface like glass, you'll get a clean, almost perfect circle. But on a rough surface like, say, concrete, that drop shatters and creates these spidery spines that shoot outwards. Every surface tells a slightly different story. And this next one, this might just be the most important clue of all: the angle of impact. A drop that hits a surface straight on at 90 degrees, that's going to be a circle. But, and here's the key, if it hits at an angle, it stretches out, gets elongated, and forms a tail. And that tail always points in the direction the blood was traveling. It's like a tiny little arrow pointing to the next part of the story. Okay, so we've got the alphabet down. We know how a single drop behaves. Now, let's start putting those letters together to form words and even sentences. And that means we need to understand the language of force. Investigators usually break bloodstains down into three big categories. You've got passive stains, which are just formed by gravity. Then there are transfer stains, which happen when a bloody object touches something else. Think a bloody handprint. And then you have projected stains. That's where some kind of external force enters the picture. Let's start with the simplest type: low-impact stains. This is basically just gravity doing its thing. You can just picture a single drop of blood falling from a small cut. The result is a clean, circular stain. It's simple, but it's still a piece of the puzzle. Okay, but now let's add some energy to the mix. Medium impact spatter. This is what happens when something hits a source of blood, like during a fight or with blunt force trauma. The drops get smaller, and their elongated shapes give us a really clear direction of travel. This can help investigators reconstruct the movements of everyone involved. And finally, we have high-impact stains. This is what you see when an incredible amount of force is involved, something like a gunshot. The blood doesn't just splatter, it atomizes. It creates this fine mist-like cloud. It's a really chilling but very clear sign of extreme violence. So we've got a pretty good handle on how to read the language of bloodstains, right? But here's the thing. The story isn't over. The language itself is still evolving. This science isn't set in stone. It's constantly adapting to our changing world. Just think about it for a second. 100 years ago, crime scenes were different. You didn't have all the synthetic fabrics and modern materials we have today. As this quote from some Boston University researchers points out, the science has to keep updating its playbook just to keep up. It's a constant race to keep this powerful tool as sharp as possible.
So we've seen how every single drop of blood can tell a story, how it can whisper secrets from the past. But as our science and our technology get better and better, it really makes you wonder, right? The question isn't just about what stories we can read today, but what entirely new truths, what hidden narratives are we going to uncover tomorrow? The story is far from over.